Okay, exercise 705 is about the chain rule. So this is a basic form of the chain rule that is not on your reference sheet. Basically, if the piece inside the brackets is linear, then you can just integrate like normal, add 1 to the power, divide by the new power. You also need to divide by the a. So in this situation here, the integral of 3 minus 7x to the power of 5, the integral becomes 3 minus 7x to the power of 6. I need to divide by my new power, and I need to divide by the derivative of the inside. So that's negative bracket 3 minus 7x to the 6 over 42. Now, I did forget my plus c here. We can never forget our plus c if it is an indefinite integral. Okay, so this second one, I'm just going to write it into index form first. So 2x minus 3 to the power of 4 on 5. We're still finding the integral with respect to x. Okay, so let's go ahead and integrate it. It is linear, so we can use this basic form of the chain rule. So we get 2x minus 3, add 5 on 5, so add 1 is 9 on 5. We're dividing by 9 on 5, so that's the same as multiplying by 5 on 9. We also need to divide by the derivative of the inside, by the a on the inside. So if I tidy that up a little bit, 5, I'll put it back into surd form, 2x minus 3 to the power of 9, all over 18. You can just put the 18 under the 5 only if you want to, so just 5 on 18 times that. Forgot those plus c's again. Okay, this is the more detailed version of the chain rule. Now this one is on your reference sheet, so I've written it here in the exact form that it is on the reference sheet. I tend to put that n plus 1 under this piece. Up to you, it doesn't really matter. So the thing we're looking for here is we've got something to a power, and in front of it is the derivative of the inside. So if you ever see something like one of these where you've got two things multiplied, we're not learning the reverse of the product rule yet. That doesn't apply here. We are just using the chain rule. So what you want to look for is what is the derivative of the inside. So in this case, the derivative of x cubed plus 2 is 3x squared. So it's 3x squared we're looking at out the front. Now, we don't have 3x squared out the front, but we do have 3x. So we can multiply by 1. So if I times it by 3 on 3, okay, I've just times it by 1, so I haven't changed its value at all. I'm going to keep 1/3 out the front, and I'm going to put the 3 inside. You can do that. You can move a constant over an integral because it's just the x's that change. So 1/3 out the front times the integral from 1 to 3 of 3x squared square root x cubed plus 2. Probably should have written that in index form. Dx. You don't need the brackets around here because this is all just one massive term in a way. It's a product. It's only when you've got a sum or a difference that you need to put those brackets. Okay, so the third stays. We do need to integrate this now. I'll put brackets because the third was out the front. So this whole thing, following our rule, we get a 1 on n plus 1 out the front. So n is a half, so we get 1, if I add 1 to half, I get 3 on 2. Dividing by 3 on 2, or putting 1 over 3 on 2, is the same as having 2 on 3. This derivative gets swallowed up. It was there, now it's not. And then I've got this piece to the power plus 1 to n plus 1. So half plus 1 is 3 on 2 plus c. Oh, sorry, it's not plus c. It's a definite integral. So from 1 to 3. Okay, I'm just going to put this 2/3 out the front with the 1/3. So it's 2 on 9, big brackets, plug in the 3. So 3 cubed plus 2 to the power of 3 on 2 minus 1 cubed plus 2 to the power of 3 on 2. So let's have a look and see what that is. I'll just tidy it up a little bit, but I'm not going to fully simplify. So that's 27, 29. It's the square root of 29 cubed, square root of 29 cubed. So I can take 2 of those 29s out the front and get 29 root 29. So I'll put that here. Minus 1 cubed plus 2 is 3. So square root of 3 cubed in the same way. Square root of 3 cubed is 3 root 3. So 3 root 3. And I'm just going to leave my answer in that form. Okay, just one more. So remember, you see a product, start by asking yourself what's the derivative of the inside, especially a product with a power involved. So over here, the derivative of the inside is 8x cubed plus 4. Now, let's compare that to what we've got here. They're not exactly the same, but there is the x cubed. There's no x here, there's no x there. What happens if we factorize this? So if I take a 4 out, I get 2x cubed plus 1. So that is the same as that. The only difference is this constant. So I need a 4. So to get a 4 at the top, let's multiply by 4 on 4. And then just shuffle our constants around. So I'm going to take the 7 out the front, I'm going to put the 4 in. I'm basically going to switch the 4 and the 7. 4 times 7 is the same as 7 times 4, so it's perfectly acceptable to do that. So 7 over 4 times the integral of 4 to x cubed plus 1 times our 2x to the 4 plus 4x, all to the power of 5 with respect to x, running out of space, sorry. So keep the 7 on 4, let's integrate. So this is now the derivative of the inside, so that will get swallowed up. I'm left with this. You can see I didn't write the 1 on n plus 1 out the front because it's automatic for me that I'm going to divide by that at this point. It will join with the 4 eventually. Don't forget your plus c. So let's just tidy that up just a little bit. So our numerator is 7. Our denominator is 4 6s are 24. I might just leave it at the front this time. 2x to the 4 plus 4x to the power of 6 plus c. Just remember with this bracket, you can write it next to the 7, you can write it next to the whole fraction, but whatever you do, do not write it just next to the 24.